I assume so.
Yes,
Yes,
So
we can.
okay, good. Oh yes, I must share my screen. This is the last one this year, guys. So I am on leave from Friday. So there is no. This is it. We've got this 1 hour to figure out the rest of PureScript, at least until Christmas. But hopefully, and then maybe what I think is a good idea is if you're feeling bored over Christmas, maybe look at that Project Euler stuff that Bhavesh sent, and maybe like try to tackle them. I've done the first couple, and they're like difficult and they're easy enough to implement in any language, but like like PureScript is a great language to run through those things because there's not a lot of like um, side effect type stuff. It's mostly, well, so far the questions I've seen have been mostly like prime factoring numbers or finding like the 500th largest prime number, those kinds of things. So pretty easy to write in PureScript. Like beginner level PureScript, to be honest. Okay, so I think today, I know we started talking about effects in our last one. So let's just finish effects, actually. I think effects are pretty simple to understand, but when you dive into the detail of effects, there's a whole lot of scary things inside there. So maybe what we'll try and do is we'll just like get it like a intuitive feel for how to build stuff using effects. And then what it'll do is like when we dive into when we unpack like what is an effect and we see this word like monad or we see this word applicative or whatever, we go, oh yeah, that totally makes sense within the context of side effects, if that makes sense. So I think we were here. I haven't actually changed this code, but I did quickly Google for reading a text file. Um, so we were talking about main, right? And we can see that main returns, so this is like its return type, right? Is an effect of type unit, which is, so when you see these two things together like this, we know that this is like a, I don't know what you call it. Maybe it's like a higher order type. So like effect is a type, which inside it is specialized with another type called unit. And remember, I think last week we talked about the difference between like void versus unit, because this is confusing here. If you recognize the word void in other languages, void means it returns nothing. There's no such thing. You cannot return nothing in a pure functional language because it's like void is the definition of like an empty set. And so it's like when you return something of type void, it's like, well, what are you going to return? And it's like, well, it's an empty set. So I can't return any of the elements. There is no element to return of type void. So void means like actually it's a function that cannot be executed in like that's the intuitively the way to think about it. A function of type void is unexecutable. It's like an impossible function. Whereas the what whereas unit is the set of one element, and that element's name is also unit, which is confusing. It's just unit with a lowercase u. So unit lowercase u is the single element of the type unit uppercase u. If that makes sense. Whereas void has no such element. There is no element. So where you see the word unit, like it's okay in your mind to think, oh, that's of type void. It would like build a bridge to type void in other language, because really what it means is it's a function that kind of returns nothing because it only returns unit, if that makes sense. But at least it can get that element of type unit. Yeah. Okay. So when we talk about main, we can see that it is an effect of type unit. So it is executable, and it kind of returns nothing. And I suppose the reason why we saw this in our example is because we saw log, right? It was like log hello world, right? Is what we executed there. So when we run that thing, we go, oh, okay, cool. It's of hello world. That's fine. So let's go and understand what is type log. What is the log function? And so you can see that the log function takes a string and returns an effect of type unit. And if you think about it, it's like that does make sense because like what does log do? Log writes something to the console. What does it return? It like returns nothing. You know what I mean? Like you would know this. Like in any other language, you would go like console.log, hello or whatever. Would you ever go like var x equals that? Like does console.log return anything? Typically not, right? It normally, like in JavaScript, I would assume this thing it's probably undefined or something, what it returns. It doesn't return anything, so it returns undefined, right? And that's true of like a lot of languages. Like if there's a printf in C or whatever, like this thing has no return type. It's of type void, right? Right? So effect of type unit makes sense. So that unit part there is almost describing what log's return type is, which is unit. It's like nothing. When you log to the console, I don't expect to get anything back, right? It's like a discardable thing, if that makes sense. So, but like, so effects. Let's talk about them quickly because we know that in this language there's no ability to create side effects. So what is this thing actually doing? So log is actually, so when we talk about effect, what it really is, it's like it's almost like a description of an effect that or of a side effect, right? So it's like if I have something which is an effect of type, and this thing could be like an effect of type string, actually. Like I could say, yes, I want to run an effect, and when that effect executes, its type will be string. So it will return me a string when it runs. This is going to give me a compile error now because log doesn't give us a unit, right? But we can make this happen. We can make this happen. Maybe not for right now. So when I see this, when you see this log statement here, you must know that this doesn't map directly to console.log. What this maps to is like a container, like a deferred execution of console.log. It's like like I want this thing to be logged at some point. Do you know what I mean? And it's like we're returning that to main. And if we think about it, like that's where our program ends, right? Our program feels like it ends here, at the end there. But there's no exit here. It's like what happens is this gets passed back into the PureScript runtime. And the PureScript runtime goes, oh, cool, you've told me that you want a log. And when I execute that thing, to give you back a unit. And so it will run it. So like the side effect is not in your code. The side effect is in PureScript's runtime. Does that make any sense? I think we'll talk about that like a bunch more, but it's like a I don't know how to say it. It's like a captured computation around a side effect, if that makes sense. So that's what effect means. It's almost like, so in another language, like a promise, right? A promise is also kind of like this. It's like I can reason about a promise even before I get its result. You know what I mean? Like I have a promise of type unit or a promise of type string. So with that, I can say .then on it, right? And I can chain that computation, even though that doesn't happen right now. It doesn't happen now. I'm creating like a chain of computation that I give back to the JavaScript runtime. It will run it in its own runtime. Does that make sense? So effect is like, to think of it in those terms, I don't think is a bad way of thinking about it. It's like a deferred computation. Totally confusing or sort of making sense?
Surprisingly making sense.
Yeah, I think the link
surprisingly. Oh, good. Yeah. So that's maybe not a bad way to think of it. Like a promise is really a deferred asynchronous result. So, right, it's making your life easier for asynchronous type of things, which are generally IO. So IO, like not a bad analogy because that's also generally side effects are captured inside promises. So 100%. I think actually like a promise is probably a monadic type, to be honest. Anyway, let's just go with that. So like, okay, so that makes sense. So then how do I like unwrap it? I suppose is the question. So like, how do I get to that unit inside this effect? And the answer is I can't actually. Like there is no way to get to that unit. Like unit doesn't make any sense because it's like who cares? Like I don't need to get to the unit. But for example, I quickly Googled this one, which is like read text file. So let's have a look at I don't know what this is inside, but it's inside the node.fs sync. So it's the synchronous file system library for Node, right? I mean, if anyone knows Node, this would look familiar. So in Node, you could go require fs, And in there's a read file sync method, which will synchronously read a file. So you can see that what PureScript has got here is just really a wrapper probably around that method, read text file. And it's the synchronous one. So, and this one makes the most sense to me because this, like, synchronous makes sense, and it'll be simpler. So let's just go with it. So the read text file method goes, okay, give me an encoding. Because we're saying it's a text file, we need to know like how that text is encoded, right? Oh, there we go. So there's like a more generic or a more low-level read file, which doesn't require an encoding because it's not making the assumption it's text. So it's just file path and effect of a type buffer, right? So buffer, just like bytes or whatever. We know that our file might be text, so then it's like, cool. Then we expect to get a string, awesome. But we obviously, when it reads that file, it needs to decode the low-level bytes into some encoding. That makes sense. So you give it an encoding, a file path, and it gives you back an effect of type string. So it doesn't give you back the string, if that makes sense, because that would like imply it executed right now. So instead of it saying, well, I can't give you the contents of the file, what I'm going to give you back is like a promise to give you back the contents of the file. Do you know what I mean? Like a deferred execution. And it's okay, so that makes sense. But like, well, what if we wanted to do something with that string? So how do we like get the stuff out of the string? And the point is, well, the way I think about this is like, well, you've got to do that with you've got to do that by like manipulating the things inside the string through the effect, if that makes sense. So we'd expect to see stuff inside effect, which allows us to do that, to like add more computation to that string captured inside effect. You can almost think of it like, yeah, let's dive into an example here. So we could go and like read a text file. Let's go and do that actually. Let's see if we can get this to work. So we're going to go import node.fs.sync, and we know that we're going to use the read text file method. This probably needs to be imported somehow, and we need to see what package it's in. Node.fs, right? So we're going to go spago install PureScript node fs. Hopefully this works. Okay, spago build, import some stuff. Okay, good. It's redundant. Yeah, we're not using it. Okay, cool. Okay, so we've got the read text file method. Read text file, there he is. And we're gonna, okay, so let's quickly, we know we're gonna run it here. So let's touch, let's just go echo stuff in file to dog.txt. Yeah, okay, so we've got a file called somewhere, it'll be here, dog.txt, which has got the contents of stuff in file. Yeah, stuff in, let's go dog.txt. Oops. Okay, we're happy with that. I don't know what encoding this is. It's probably, do we see it down here? It's UTF-8, right? So our editor saved that in UTF-8. It's probably quite meaningless. We're not using any fancy characters. So, but we could assume that. So let's go and do this. So we're going to make our main method. It's going to read the contents of the file, and then should it log them? Yes, maybe it should. That's going to be hard, but let's try. So we're going to go read text file, and we need to pass that encoding. Let's click it, see where encoding comes from. Encoding comes from node.encoding. Okay. Import node.encoding, and look, there's a constructor called UTF-8, which is of the algebraic data type called encoding. So do we remember this stuff? So it's like there's a type called encoding, but there's a few ways to construct that type, and it's like, oh, here's its constructor. So if we go and click on the source, I generally like to look at the source, and it's like, oh, okay, makes sense. So it's like, oh, there's a type called encoding. That's fine, but we can't construct that thing. We have to call one of its constructors. So, and we can see we can just call UTF-8 with no parameters, and we get it. So that's awesome. So when we import it, though, we can't import the constructor there. We need to import the type, which makes sense. So I can import the encoding type. The problem is I still need the UTF-8 constructor there, and it's like it doesn't know what that is. So it's like we need to import that constructor from that type. So the way you do this, I don't know if we've dealt with this before, but you kind of do that. So you're saying we're importing node.encoding. We want the type encoding imported as well, but only one of its constructors called UTF-8. I think we could have gone like, I want all of them like that. I think that would have been fine, but we can be specific that we just want the UTF-8 constructor. So literally we've imported like just that little element out of this package. And depending on your personality type, that may make you feel very happy or very sad that it's that specific. Okay, so let's go back. And then I think it was file path. Oh, this could be confusing. Let's see how a file path works. Oh, thank goodness. A file path is just a string. Is that right? Yes. It looks like it's good. So it looks like it is just a string. Type file path equals string. Brilliant. So there's no constructor for that type. It is just purely, it is the same as string. So I think I can just go dog.txt like that. Should be good. Yeah. And what does it give us? So read text file gives us an effect of type string. So I think my compile error probably says, could not match type string with unit, right? And so it's saying, so if we type this, like let's just add, like put some type information in here so we can see it nicely. If we say like x equals this, we can say, hey, x we know will be of type effect string, right? Because read text file gives us back effect of type string, right? So we know we're calling the first two, we're giving the encoding, we're giving the string, we expect to get effect of string, so x is going to be of type effect of string, and because we're returning that, I'm just going to return it there, it's going to say, oh, okay, but that's an effect of string, your method promised that it would return an effect of type unit, so unit doesn't match string. Yeah, happy with that. So it's actually done the type checking inside the types, which we'd expect. I think that makes sense. It's kind of like list of int is not the same as list of string, like they're not the same. The compile error, though, when I look at that, I would have probably been happier with it saying could not match type effect of string with effect of unit. Here it's going, oh yeah, the effect is common, so that's cool. Now it's string and unit, and that may be confusing. The cool thing about, well, it's not that cool, but like it's like we can fix this by saying, actually, you know what, main returns effect of string. So like we can just fix it up there, if that makes sense. So it's like, well, it's fine. Like the PureScript runtime probably doesn't care about what's captured inside the effect. It probably is specifically like of type main, like when it thinks about main, it's probably effect of A. It doesn't care what's captured inside it. It's just going to execute the effect and probably throw away whatever is inside it, because I don't think it's going to log it or anything, but let's try. So let's see what happens when we run this thing. Spego run. Kind of expect nothing to happen because I'm just like reading the text file and giving it back to PureScript to say, hey, like, good luck. And it doesn't care about it, right? So at least what we've done is we've gone, okay, yes, we can read a text file. Like, brilliant, right? So the next thing we wanted to do is we said, actually, like, don't we want to like log maybe the contents of that thing? So instead of returning X, the effect of string, we actually want to go like log of X, right? Something like that. That's kind of what we want to do sort of dumbly. Does that make sense? Here we're going to get something really batty because it's going to say like, yeah, but like log, when you call log, that needs a string, right? We know that. It needs a string, not an effect of string. So X is an effect of string. So it's like, well, you can't really do that. So you can't pass an effect of string to a function that wants a string. So it's like, okay, I got it. So it's like, so that's a bit of a problem. What we want, though, is we want to somehow join the effect of string with the effect of unit. So we want to join somehow like the read text file with the log thing, so that when read text file gives us back the string, we want that sort of passed into the log function as a string. But the total thing needs to be an effect still. Do you know what I mean? It's like we want to compose read text file with with log at some level, if that makes sense, right? Does that kind of make sense? Like, does it make sense that you can't do this? Because what it really wants is a string, which is like stuff in the file. Sorry, that needs to be an equals. So like we could do this. We could go log of y, yes, because y is actually a string. Now it's saying that needs to be a unit, which it needs to be now. So like, yes, y is a string, so we can log that. X, though, is not a string. It's like a promise of a future string. So we can't just log that thing, right? We almost need that like dot then piece. You know what I mean? That promises would give you. They would unwrap the object. So let's try and figure out how to do that. I would start with going, let's go look at the type effect, because we know we want to compose stuff in the effect world. So let's go and look at effect. I imagine it's this guy. Yeah. So this module provides the effect type, which is used to represent native effects. Effect type provides a typed API for effectful computations. So effectful computations, meaning computations that have effects, like reading a file, writing a file, making an API call, updating a database, while at the same time generating efficient JavaScript. Okay, good. Here's what it looks like as a type. Who cares? Here's the intro. Here's where I would go generally. Is I go, okay, cool. So I've got this type of effect, and I want to know what I can do with effects. So it turns out that it is itself a data. So it's a data type, but it's implemented a bunch of instances of stuff that we can do with things of type effect. So like the first one is Functor, right? And maybe some of us know what a Functor is, but actually a Functor is a really simple thing. If we just click on Functor, we can see which supports, so a Functor is a type constructor which supports a mapping operation map. It's like, oh, actually we all do know what a Functor is. A Functor is any kind of, it's kind of like that IEnumerable concept, right? We talked about it. So map, it just needs to have a method called map on it, which is, hey, given a function going from an A to a B, and then an f of type A, I will give you an f of type B. Does that make sense? So this could be like, if this was a list of int, it would be give me a function which goes from an int to something else, because maybe we want to map from a list of type ints to a list of type strings. So A would be an int, a function that goes from an int to a string. Given a list of ints, give me a list of strings. Does that make sense? Have we looked at these kind of signatures before, where there are two thingies? It's like a generic of two types. I think you'd call these higher order types. So like where the F could be of type list, or it could be of type effect, or it could be of type, what are the types have we seen? Like a tree or a like something, right? It's like a higher order type. I don't know if we looked ever at making that specific. So it's like, but it's actually quite intuitive if you think about it. It's like, oh, it could be list, could be map, it could be tree, could be effect, it could be, it's anything of something which takes another type. So it's any type which itself takes another type, like list of int. It's like there's two types. List requires a type. Int doesn't require a type. Like int is a thing. Does that make sense?
So?
Yeah.
Oh, jeez.
Shoot, how's it?
Yeah. Okay. What would kind of concern me a little bit there, or something I'm not sure about, is if I remember correctly, you can use like guards to map different types to different outputs.
Okay.
So now let's imagine that if there was, say, a function which mapped different types to different outputs, then if A and B are different types,
yeah,
what happens?
Well, it's okay because you have to provide the function that shows it how to.
You have to provide the mapping. Hey, yeah. Okay.
Yes.
Cool.
So it's generally okay. So it means that the basic implementation of map doesn't really care because you're kind of giving it everything it needs. like you would have to be very specific as to how that mapping occurs right there.
Yeah, cool.
It's really what's
Cool.
happening though is it can happen underneath that type without having to know about what the F is up there. If that makes sense. So like as long as you just give it the thing that deals with a single element, it doesn't care about the type of like the container, what holds it. So this is quite interesting because we can even use map in our funny little context here where we've got this like X thingy which is set to like the effect of string, which is going to give us the contents of that file. We could technically we could map this actually. So we could, because if you like map, like we can do this. So it's like we can say, okay, cool. So I don't know where we want to do it, but let's just do it here. So we'll go Z equals. So we take X. So we could call map, right? And the first function is like, okay, it's going to be a string to a string. So it's like, okay, let's take that string E, and we'll just like we'll append mapped or something to the back of that string. There's our function, which is going to go from a so in our little definition we want, so let's take this guy map. I'll just write a comment so we can kind of replace it. Here's the function, which is this one here that we're going to pass, and we're going to say actually like we want to take it, we're going to go from string to string. So A and B are both string, so we're going to go from a passing your function which goes from string to string, which is this one, given an element E, just append the word mapped to the back of it, right? So that's string to string. The F of type string is actually, we're going to make this effect and effect. So then we're going to give you the effect, which is this one, X. And that's going to return us now a Z, and let's just type it properly, which is of a type effect string, right? So effectively what we've done is we've said, yeah, okay, working under the effect of X, like let's just map the contents of what it holds to some other contents. Do you know what I mean? So it's like we've manipulated the computation without executing it through map. So we've mapped it from one type, which is of type string, to another type of type string, but we've manipulated the string inside it without executing that effect. Does that make sense? So well, I'm not logging anything yet, but the compiler is happy with that. So like map was pretty interesting, actually. So map you might think of initially, you go, oh yes, map is the way I just move from collections of things to collections of other things, right? I map through something. But it's like here, actually, we're not doing that at all. We're using map. This effect is not a collection. It's like it is, I suppose, in some context, in some way, a container of something. But it's like, oh, but I can also map it because it is itself a functor. Any weirdness there? It is weird. Weird, but like it should, like it makes sense, right? So you will find a lot of types out there. So anything that implements the functor type class, you are able to map that thing. You are able to map it as though it were a collection of things, even though it may not be.
So, Tom, is this accurate to say, sort of, hey, Mr. Compiler man, you know this thing that you promised to read me? While you're promising that, just promise to add this word map to it as well.
Yes. Yes, exactly. Yes. So if we had to like reduce this to promise world, I think it's okay to think of it like promises. I think it's bigger than promise, but let's we would be going like read file, you know, whatever, dog.txt. Sorry, I'll make this like a thing. So make it look like JavaScript, and then we'll go dot then, and that would be given like the contents of that file. Does that make sense? And then what we're saying is we're saying, oh, cool. So contents, you know, plus this is string append mapped, which would then we could dot then on again, like contents again, right? I don't know if that's perfect. ES6, something like that, right? So because we know promises, promises can either return a value, which is like, oh, okay, that's what that would be. It's like almost like that promise is now resolved with this value, or it could return another promise, right? So promises must always either resolve to a value or resolve to another promise, or of course reject if they fail. Because they can fail, right? Because here's something interesting is like, what if dog.txt doesn't exist? So if this effect of type string is like, this is more like a promise. So this is more like a promise where it's like, yeah, I promise to give you a string or at least fail. It could fail. And so then what will happen with map? I don't know. So it will be like, probably it won't map because it's like, well, I can't give you this element. So it's like the effect will be failed. You know what I mean? The map won't execute because there is no contents to execute. But that's actually up to the implementation of map for the effect type. So we could go and read it and go and look at what it actually does. We could probably just make the assumption that it probably works a lot like promises, where errors or rejections or whatever bubble down properly. Okay. However, so map works for us. Like we can manipulate the string inside the effect. What we can't get yet is the string itself. So like we can get it here, sure, but it's like I want to log it, right? Like we know that we want to log this thing to the console. So it's this, and map's not going to give us that. Like we know log goes from effect to string. It's of type. Given a string, give me an effect of type string. So there's probably something else we're looking for. So let's look at the other instances, right? So there's apply. I'm going to ignore apply for now. Applicative is another interesting one. So applicative is actually super useful. So it's like, and look how simple it is. So the applicative class is, so it derives from type apply. So we can go and understand it, but let's ignore it. But actually it's very simple. So it's like, given me a type of A, I will give you an F of A for all types. So that's very interesting. So it's like, and it's called pure. So it's saying, oh, okay, so given a string, I can give you an effect of type string, or given an int, I can give you a list of type int. And if you think about it, it's like, yeah, that totally makes sense. So, so anything which has the applicative type effectively can construct one of these things from one element of it. So it could be like A equals pure. So we can say A is of type list of int, right? And remember, we were going to say, hey, like say we wanted quickly one element in a list, we would go like that. There's one element onto the empty list. That's A is now a list of int, and our compiler should be happy. It's not happy because it doesn't know about what lists are. So we need to import data.list, and we want the list type, and we probably need we need the cons operator, and we probably need null. Yeah. Because we use null and we use the cons operator, we have to import those things, and we need the type list. So there it is. So we could construct a list like this, one onto an empty list. If we just wanted a single element list, though, we could also go and call like pure, because probably, and this is getting like a little bit sidetracked, but let's go and have a look. So if we go and look at list type, a lazy linked list, this is lazy type, so I don't know if that's what we're using. Maybe we are. I don't know if we're using lazy, but who cares? If this thing has applicative as an instance, which it does, so there is an instance of applicative of type list. This is of lazy list, but I think we can assume that list itself also has it, the non-lazy version. So that means we can actually call pure. So we could call pure of 1 as well, because this will go and find the pure implement, the applicative, the function called pure inside the type class applicative for the type list of type int. Does that make sense? Interestingly, like if we leave this off, if we leave off the type of it, it's going to say like, yeah, but like it could be of anything. Like the value 1, it could be a list, it could be an effect, it could be an anything. Like, so what is it? And so to help the compiler, we have to say, dude, it's a list of int. And then he goes, oh, okay, cool. So now I know which pure to call, because there's a million implementations of pure out there. Everyone who implements the the instance of applicative will have implemented a function called pure. So we do have to help because we're being so we're being very broad here by just passing one. The compiler's going like, dude, I don't know. This could be an effect of type int. So I don't know that it's a list. Do you know what I mean? So we have to give it a type hint for this very stupid scenario here. Does that kind of make sense? So it's like so now we know what pure does. Pure is without like getting into what is applicative. It's like actually we know what applicative is. Applicative is any type which can lift this into a higher order type, like list event. Yeah. So we could also say, so let's use it as an effect. We could say, well, okay, so we want an effect of string, like let's just go pure hello dog or something. And it's like, oh, okay, cool. So we've created a value A, which is of type effect string, and we've just put a string into it already. It's almost like this would be very similar to if this were a promise to say just like promise.resolve that. It's just like it is this. It cannot be a failure or anything else. It's the string. Do you know what I mean? So that would be pure. And I suppose it's called pure because there's certainly no failure case here. There's no way of failing. It's always a string. It's like it doesn't. There's no doubt about it, right? It's pure. It has no side effect. Actually, this line has no side effect. So I suppose that's why it's called pure. So this is useful, but it's not really. It's not going to help us yet with getting access to that string so that we can log it, right? Not really. It will allow us to create another one. That's pretty handy. But we're not quite there yet. So let's look at the next type class, bind. So let's look at what bind does. So bind says extends the apply with a bind operation. And look, it looks like I don't know what that looks like a little spaceship, which composes computations in sequence using the return value of one computation to determine the next computation. This is looking good, actually. So it's like, ignore the do stuff for now. Let's just go look at the signature. So if we look at the signature of bind, I'll just take that part. Let's just put it there. So it's like, okay, given something of type A, so let's just go and replace this with our words that we're using. We're using effect of type, it would be effect of A. So let's just replace M with effect wherever we can. So if you've got an effect of type A, and we know this is of type string, so A is a string, okay? And a function which goes from a string to an effect of type B, I will give you back an effect of type B. And we know that what it does is it computes them in sequence. So this is the dot then operator, 100%. Is bind. So let's like make it meaningful. And we know that B is a string there as well. But let's call it B for now because A is also a string. So let's try and join these things. So we know that log actually already matches that signature there, doesn't it? Log takes a string to an effect, okay, of type unit. That's cool. So let's actually do that. Let's make that unit. Yeah, so we've got an effective string. We've got a function called log, which goes from a string to an effective type unit. And we want to return an effective type unit because that's what main wants up there. So actually bind is going to work for us. So let's just do it. We're going to go bind. We're going to take I'm going to kill some of, okay, I'll keep them. We know we want to bind X. That is our effective string, right? Bind X to log. Yeah. So we're using bind, and let's see what happens. So if we run that, it's like, oh, stuff in dog.txt, brilliant. So it's like effectively what we did is we did the dot then. We took the contents out of the string, and which was X, and we bound that onto the next function called log. Yeah. It looks weird when you write it like that. There is this cool operator called rocket ship, which maybe makes this look easier or harder, but it like could look like that as well. So x then log. I suppose you could say the word then there if you were in promise thought. Does that make sense?
That's really cool. I like it.
And it sort of makes sense. It's like we're
It actually makes
working.
sense.
Okay, good. It didn't make sense to me when I first looked at it, Trickus. It was like, but maybe the promise thing is actually a good route into understanding this. So here's an interesting question. It's like, what happens if this file doesn't exist? So I'm saying, hey, read the contents from dog1. What do we get actually? It's like, oh, some error. So certainly what didn't happen is like log did not execute, right? We don't see any logging of stuff up here, right? Not really. Yeah. And I suppose we could have made our own cool log function to prove that. So we could say like log prime equals like, so given an input, so this will be string to, we want to execute log, but we want to take that, and we're going to add something to it, like about to log something, right? You know, something like that. So there's our log function. Let's bind that with our fancy log function. Oh, it doesn't like it because it wants it needs to return. What's the problem here? Oh, log of input. Yeah. We can't just do this because why can't we actually? So this thing takes a string to, oh no, I think we've just got a compile issue here. Effect of unit, and I think we're going to see our thing move to there. Yeah, okay, it's because that string concat, just trying to concat to that, which we, like it's a bracketing problem, right? So now we can. So if we run that, we certainly don't see the about to log, you know, thing being logged up there. Whereas if we make it successful, about to log should come. So it's like, okay, so we can kind of start to understand what bind does in the context of effect. It's kind of like, oh, okay, if there's success, if it's successful stuff, then carry on doing it. But if there isn't, then like stop the effect bus. If that makes sense. So very much like .then in Promise World. Of course, we can do this. We can chain this, right? So we could go, hey, like put that onto log again or something. And here we're gonna. So it's like, so do the X thing, then do the log thing, then do the log thing. And so why is there a problem here? Like, why can't we do the log thing again? You want to try and answer that?
The return type of the log doesn't match the input of the other log.
Exactly. Yeah. So that early log gives us an effect of unit, right? And it's saying, well, this log like doesn't take a unit; it needs a string. So that totally makes it. So this little bindy thing, this little bind operator is interesting because what it allows you to do is work with the type underneath that type. It kind of like it binds the inside types together while working within the construct of the outer type. That kind of makes sense, yeah. So like they still have to match. So that unit, because we're going log to log, which is a bit batty, that unit needs to match that string, which it clearly doesn't. Do you know what I mean? So we could say like we could create a new thing called like log end or something, which takes a unit and goes to an effect of unit. That would be fine. And log end of like nothing. So like given zilch, like unit, I mean, we can name it if we like, u, then just log, this is the end. Like, but it didn't get given anything useful. So we probably just underscore that and say, well, this is the end. And we could go log end here, I'm hoping. And now it kind of matches because it's like, it goes from a string to a unit and then a unit to a unit. Through, you know, the way you would read that is like, just take away the effect at the end part and join the thingies together. Yeah. And so I suppose if we run this, I suppose we need some proof that it works, but it does work, right? It does the log, and then it says this is the end.
So this would be, like you're saying, the promise then, but and like promise then is essentially like a type of pipeline in non-functional languages, right? Like async await as well in C#, where the underline is task
Yes.
dot continue with, continue with, continue with, continue
Yes.
with. Will you
Yes.
do something else there?
Yes.
So I'd say that's
Exactly.
but would this as well then be seen as like pipeline into a degree for promises or for effects?
Yes, I think so. Yeah. I would totally like think about this as like a chain of effects that are running. So it's like do this, then do that, and then do this, where all three of them can fail. You know what I mean? They all have the potential of failure. So it's like it will do these three, assuming no error. But if this one fails here, it's not going to do this one here. The same as the way a promise would do this too. You know what I mean? Like a promise breaking here would stop the execution down that chain.
Yeah, it would jump to the catch clause. Yeah, actually,
Yeah, it would jump
curious,
over it, and it would reject to the end. Yeah.
what would be the equivalent of like a try catch or so, since we're now getting closer to seeing errors, like when things go south?
Yes. Okay. So how would you? So your question is like, how do you model that? So keep in mind, in a pure functional language, there's no such thing as a runtime error. I say that quite broadly, but you can't catch. There is no runtime error in the language. It's not really possible to create it.
Is that where like maybe comes in? It's like I'm either going to give you back what you wanted, or if I fail, I'm going to
Yes.
give you back nothing. And please, you need to know what to do with this.
Exactly. Yes. So maybe is one of your weapons, but it can be a bit of a blunt weapon, right? It's a bit too course. So like if you think about it, so it's like so let's pretend that we're doing a like a function that's going to, I don't know, it's almost like a user permission or something, right? So I go like perform action, right? And I'm going to say, hey, I'm going to give you a string, which is the name of the user, and then I'm going to give you a string of the function that I want you to perform or something. Like I suppose we could let's actually make it cooler. So let's go data action equals I don't know, fetch balance or make payment. Right? These are the two actions I can do in my system. I can fetch my balance so I can make my payment, right? We also have a data user equals user and string, right? So we know we've also got a type called the user, and we can construct that by saying user, and we give it the type string. So this is so that we can write cool signatures here. So user action, and then like we've got a data. Let's just go with maybe. Yeah. So we're going to say cool. We're building a function called perform action. We're going to give you the user, give you an action, and we want some kind of result. And let's say for now, we'll just say, well, you might get a string, maybe string, perform action. Does that make sense? So it's like if it works, you'll get a you'll get a just result, and if this fails, we're going to give you a nothing, right? Because we know what maybe looks like. I don't think we've actually talked about maybe. So maybe we don't know what maybe looks like, but maybe looks like it has a type called maybe, and it has two constructors, just and nothing. Oh, it's two constructors. So it's like a nullable thing. Either it has a just and a value, or it has nothing, which is null. If you know, think of it like null. So when you go maybe string, it's like it could be a string or it could be nothing. Okay, so then we can say, like, let's actually just type match this. We'll just go in general, so we'll make a catch-all. So given anything and anything, we're going to give you back nothing, right? So this is like the deny otherwise stuff, right? But if you are a user. So now we deconstruct. If you are Tom and you are going fetch balance, then we go just, okay, that worked, or something. Your balance is $5, right? So check how cool that is, actually. Look, we're like building a proper system here. So here's our rule definition. It's always nothing. So like you denied, no dice. Unless you are Tom and you're fetching your balance, then it works, and you just get your balance as $5, right? Does that make sense? So we can of course say, let's just make another case, and we can say, well, if you also Miguel and you are making a payment, then you paid someone. So Miguel can make payments, Tom can fetch balances, no one else can do anything else, right? You're going to get nothing. Are you happy with that? So sometimes though, so this is using maybe to describe like a failure scenario, because you say, well, all failures become nothings. But sometimes you want to say, like, that's not good enough. I also want to carry a value as part of this error. Do you know what I mean? And so there's another cool type which is called either. And so either describes like two alternates, a left path and a right path. It's just kind of like a more powerful maybe. It's like a maybe, but where nothing carries something along with it. And so you can see actually it's described as left and right, which is brilliant. So generally left is the error scenario and right is the success scenario. And the way I remember it is like, well, if it's right, then it's correct. You know, like the correct side is right and left is therefore the incorrect side. So now we could rewrite this scenario using either. Let's just try it. So instead of it going to be a maybe string, it could be an either with, and so either needs two types. So it needs an A and a B. They're not the same type. They could be the same type, but they don't have to be. In our scenario, they probably are, because it's like the error is going to be a string and the success is a string. So the left side is string, the right side is string. We just need to import this thing. We're going to go import data.either, and we need the either type with left and right imported. Okay, so there's our new signature. And now it's saying, okay, but you're returning a maybe here. You need to return an either. So it would be like, okay, we know this is right. This is a correct scenario. So we're going to say right that, and this is right also, but this is not right. This is now left, and it's like, oh, we can now give it a string to carry along, like, you know, you are denied access or something. Do you know what I mean? So there's like the error message that came for this particular scenario. Do you know what I mean? And of course you can have many. Of course it could be, if it's Miguel, then you could say, oh, you are not an admin or whatever. So you can be more specific about your error here. So interestingly, when you look at this either type though, is like, oh, look here, it's got some cool type classes attached to it, like bind again, which we saw, oh, you can chain these things. Isn't that interesting? So it's like, oh, so maybe we could chain stuff together. So as long as our functions are all of type either, ethers can be chained together, like all the right paths versus all the left paths. Do you know what I mean? Like you can chain. So this is totally your try-catch mechanism. It might not be that obvious to you right now, but it kind of is. Yeah.
Actually, yeah, the fact that it has the bind actually makes the ligature that the font I use converted those angle brackets and it equals to the little rocket ship. Makes a bit more sense now as well as a ligature, because I would assume you could say, okay, if it returns a left, you go down this path, and if it returns a right, you go down this path. So because of it being an either, it's like, yes, either go down these methods or go down these methods based on what you returned.
Exactly. Okay. Yeah. And I do think though, so what bind will do it's my assumption, is that it will continue to execute down the right path, but on the left path, it will resolve the last error up, if that makes sense. Allow sequencing of either values and functions that return either by using the bind operator, yes, but I don't know if it will bind down the left path. I think generally left is like left and right are not equivalent in the world of either. Left generally is like assumed to be more of an error, and right is assumed to be more of a success. And so bind could choose. I mean, we can actually go and maybe look at bind. Ooh, bind of either A. I don't see any source code here. How do I get there? There. Whether it prefers a particular route, or whether it's going to do the same thing. Yeah. Yeah, so we can actually see what it does do. So, I mean, without going into too much detail, but we can say that bind, you can kind of see that on the left side. So if this either that's passed to bind, so the left part, if X is a left, then it is left. Then this is also left. Whereas if it's right, then it's like, then like continue. Do you know what I mean? So you can almost see it like left of E, otherwise it's a type, I don't know. It feels to me like that's going to escape the rest of the chain because it's like defining it as left on the left side. Anyway, I don't know. We can experiment. Like, I think this is a good thing for you to experiment with, actually, is like, because now you've kind of got everything you need to play with this stuff, is like to play with chaining, with this chaining idea. Because, and you don't even need to actually read a file here, because we know that we could just replace this with pure. You know what I mean? Pure with the contents of dog.txt. Like, let's pretend that's the contents. So if that makes sense. You don't actually even need a file. That's what I'm saying. You can play with effect of string without actually causing effects. And you can map them and you can bind them. The other interesting pieces that are worth looking at is monad. Look, I said we would use the word monad. Actually, monad is pretty simple. So monad also, he introduces, it gets confusing because it introduces a bunch of new like operators. But like I tend not to start with the operators, but start with like, well, what does it do? Like what functions does monad have on it? So let's have a look. So monad, it's got these instances fine. And these are the methods, yeah, that are kind of like implemented as part of the type class, which is like lift M1. Okay, it's also a terrible name, but if you look at the signature, it's like, oh, and so given a function that goes from an A to a B, like a string to a string, and I've got something which is a something of that type A, I can give me back a something of that type B. It's like, oh, we can use this. We can use this. We had this problem earlier. So it's like, it was kind of this problem when we were mapping earlier. It's like, oh, we want to take, let's actually just call this. So we'll go lift M1, and then a function that goes from a string to a string. So given an E, give back the, I don't know, we're going to say lifted or something. And then an X, that will give us back an effect of type B, which is, okay, effect of type string now, which is interesting. So that's probably our compile error, is that one there is a string. So it's like, oh, okay, so it's effectively map. It's kind of the same as map. Does that make sense? But we could have just written it like this. So instead of that guy, we can say like that. Take X and append to it. Actually, we could call that X to make it like even more confusing. Something like that.
Tom, I think
Something like
it's
it's
just
really.
you and me left, and I also
I
need
know.
to go to
We're one
another
minute over.
meeting now.
Have a good Christmas, Drickus. I will
Cool.
speak to you
Cheers,
next year.
Tom. Enjoy the leave.
Cheers, man.
Cheers, bye.